Hey folks, Opie Taylor here. This statistics lesson is on probability models, and we're going to be just discussing sample spaces and everything. So that's a pretty easy lesson. Let's go ahead and take care of this. This board problem's off, I believe, by one. So all of my board problems are going to be off somehow by one. So anyways, this is board problem 31, or it might be 32 or 30, I forget. So whatever's consistent with you guys. Okay, control groups are used in experiments in order to A, control the effects of lurking variables, such as the placebo effect. That one sounds pretty good. B, control the subjects of studies so as to ensure all participate equally. No, that one's not it. That would be like a simple random sample. So when you're controlling something, you want to control lurking variables. I think it's A. Let's see. C, control or guarantee that someone other than investigators who have a vested interest in the outcome control how the experiment is conducted. No, it's not that. So achieve a proper and uniform level of randomization. No, that would be a simple random sample. Yeah, it's A. Control groups control the effect of the lurking variables such as the placebo effect. Okay. All right, so let's go ahead and get started. Here's some probability models, you guys. So this is just on page 336, you guys. A sample space, that's what we'll be discussing in this lesson, of a random variable, of a random phenomenon is a set of all possible outcomes. So we're going to be listing all the possible outcomes of sample spaces, okay? So an event is any outcome or the set of outcomes of a random phenomenon. So we'll be talking about each event. So each event makes up your sample space, and your probability model is a mathematical tool that you'll be talking about in the next lesson. Probability, you've seen probability before. We'll talk about that in the next lesson. Okay, let's go ahead and get started. So we're going to do the sample space of rolling a dice, you guys. So rolling two dice is a common way to lose some money in casinos. There's 36 possible outcomes. I'll show you in just a second when we roll two dice and record the up faces, they call them, in order. So the first dice and the second dice, they're listed as ordered pairs. You'll see in just a second here. So here's rolling the 36 different ways. I can roll a 1 on the first dice, a 1 on the second dice, a 1 on the first dice, a 2 on the second dice, a 1 and a 3, a 1 on the first dice, a 4 on the second dice, a 1 and a 5, finally a 1 and a 6. Okay, then I can roll a 2 on the first dice, a 1 on the second, a 2 on the first dice, a 2 on the second, a 2 on the first dice, a 3 on the second. Here's all the way to a 2 on the first dice, a 6 on the second dice, all the way down to a 6 on the first dice, a 1 on the second dice, a 6 and a 2, and all the way to a 6 and a 6. There's 36 different outcomes. This would be the sample space, okay, of the 36 different ways of listing those. Okay, so rolling a 5 is an event called A that contains 4 of these outcomes. So rolling a 5 means the sum of the numbers, you guys. So I can roll a 1 and a 4. So a 1 on the first dice, a 4 on the second. I can roll a 2 on the first dice, a 3 on the second. I can roll a 3 on the first dice, a 2 on the second. Now these are two different rolls, you guys. And then I can roll a 4 on the first dice and a 1 on the second. So there's 4 different ways I can roll a sum of 5. Okay, makes sense? So gamblers care only about the number of pips, which are the numbers on the up faces of the dice. So the sample space of rolling 2 dice and counting the pips is you can get, and so it's just the sum, you guys. You can get a sum of 2, a sum of 3, a sum of 4, a sum of 5, a sum of 6, all the way up to, if I got 2 6s, I'd get a sum of 12. So that would be a sum of rolling 2 dice and counting the pips, or counting the sums. That's, you know, they're getting a little fancy with us here. So anyway, so here's another one. Picking a random digit gives the sample space, and now there's 10 digits here. If I just picked a random digit, I'd have, that would be my sample space right there, 0 through 9. Okay, flipping a coin and rolling a dice. Here's a tree diagram of flipping a coin, okay? So it's right here. Here's I can flip a coin. I can get a heads or a tails. Now let's say I get a heads on the first, when I flipped a coin. How many ways can I roll a dice? I can roll a dice 6 ways. Even if I got a tails on the first dice, I can still roll a dice 6 ways. So I can get a heads on the, I can get a heads and roll a 1, or I can get a heads and roll a 2, a heads and roll a 3, a heads and roll a 4, a 5, a 6, or I can get a tails and roll a 1, a 2, a 3. So there's 12 different outcomes right here, and so there they are. There's my sample space of my 12 different outcomes right there. Okay, makes sense. So I think you're just listing your sample spaces. So the sample space is heads 1, heads 2, heads 3, all the way up to heads 6, and tails 1 through tails 6. Okay, there's 12 different ways. Okay, what about if you flip a coin 3 times? So list the sample space. So we're going to go ahead and do this. Here's my first flip. I can get a heads or a tails. Now let's say I get a heads on the first one. And my second flip, I can get a heads or tails, right? So there it is right there. And then if I roll the tails, I can get a heads or a tails on the second one. Let's do a third flip. I can get a heads or a tails, a heads or a tails, a heads or a tails, a heads or a tails. So there ends up being 8 different outcomes right here. One outcome is getting a heads on the first one, a heads on the second one, a heads on the third one. Or I can get a heads on the first one, a tails on the second one, a heads on the third one, a heads, tails, tails. You see what I'm talking about? So here's my sample space right there. Heads, 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 tails, heads, tails, heads, heads, tails, tails, and so on. There's 8 different ways I can get of rolling 3 dice right there, okay? And this would be my sample space right there, okay? So if they said list the sample space of rolling 3 coins, you'd list all of these guys right here, okay? And then here's a way to flip 4 coins. This is another way than doing the tree diagram right here. So this figure I got is to list it 0. You list all the ways to obtain 0 heads, and then all the ways to obtain 1 head, all the ways to obtain 2 heads, 3 heads, and finally all 4 heads. And here it is listed right here. Okay, here's all the ways you can get 0 heads. Here's all the ways you can get 1 head. Okay, I can get a head right there, a head in the second position, a head in the third, a head in the last position. 2 heads. Okay, I can get a heads, heads, tails, tails, or I can get a heads, tails, heads, tails, or I can get, this is the first flip, the second flip, the third flip, the fourth flip, okay? So there's more ways to get 2 heads and then 3 heads, and notice the symmetry, you guys, and this is make a nice symmetrical bell-shaped curve, upside down bell-shaped curve. Okay, if you pull a card from a standard 52 card deck and then pull a second card, okay? It depends on if you replace the first card after you look at it. Then the second card would be completely independent of the first card, because if you put it back in, you'd have 52 cards left back in there. Okay, but if you left it out, there'd only be 51 cards out. So if you pulled the first card out and you didn't replace that first card, then the second card is dependent on the first card. Okay, if you put it back in, then the second card would be independent of the first card. All right, so that's it. If you're in my stats class, that's going to be the homework assignment I would assign you guys.